Hello, my name is Ryan Page and I'm an application specialist for Tekla Structures. Today in this video we're going to be discussing creating transitional concrete parts. That is to say, a piece of concrete that has one profile at one end and another profile that is slightly different or completely different on the other. Now there's a few methods to go about doing this inside of Tekla Structures. We're going to be focusing on one specific method to create our profiles today. So let's go ahead and check out what we'll be using as our example today to help us understand the concepts of creating transitional concrete pieces. So here we have a concrete barrier that transitions to a termination where a steel barrier is going to be attached and continue onwards. Up at the top we have a plan view and then an elevation view here shown on the drawings. And then below we do have three defined profiles that correspond to section cuts. The reality of it is that we're beginning with a standard profile at one end and we are transitioning to another. So it's from section A to section B type thing. And that's what we'll be using for our example today. So when first setting out to model this, after we understand what the requirements are for our concrete, is to ensure that we have the correct profile in order to create our concrete parts. Now in the example of a guardrail, I'm probably going to use the beam tool. So the first thing I would do is go to our catalogs and then profile catalogs to inspect some of the various shapes, most likely found under others in either various shapes for some of our more interesting and rectangular or trapezoidal shapes, as well as perhaps even some transitions that already exist that we could use. But by and large, if we find a shape that is not in the profile catalog, we can create it ourselves. There are many different methods we can use to create profiles inside of Tekla Structures, and you can find those methods through the catalogs and then define profiles option. Probably most of you with any experience with this would think to use the sketch editor or sketch solver, which can be downloaded from the warehouse, to define a parametric profile, one that you can change the values and dimensions of. And that is a viable method if you will be reusing the shape time and time again from different projects. But if this is a one-off kind of task for your project, we're going to use something a little faster and a little bit more direct. We have the ability to define cross sections using various methods, such as picking a polygon or bringing in a DWG. But for our demonstration here today, we're going to define our profiles, our cross sections, using a plate. So the first step is to actually model the profile with the plate tool. So let's go ahead and take a look at how we can do that. So in order to create a transition piece, we must have a piece before and therefore after, and we're going to go ahead and create those profiles for those pieces as well. You know what? Tekla doesn't have them. As I said, we're going to create a steel plate and create a profile from that. And the first step that I would proceed with is using construction lines to lay out my geometry and make sure that I haven't made any mistakes. You don't have to do this, but it is helpful. And I also like using the steel plate method as it does provide a visual for me to confirm that my profile is correct. You don't need to necessarily follow that. The choice is yours, but here we go. So laying out the construction lines and then tracing that boundary with the steel plate tool is all that is required. You can provide a specific name to these profiles, but it isn't necessary, as you'll see here when we go to the dialog box. Now that we have our cross sections defined as steel plates, we can go ahead and create profiles for the profile catalog. Keep in mind when we do this, it's only going to be saved to the local model here, not into a firm folder or anything like that, although you can export this if you want to reuse them in the future. But let's go to File, Catalogs, Define Profiles, and then choose Define Cross-Section using a plate. It'll bring up this dialog box. There'll be an image that does not represent your current profile. Don't be thrown off by that. It's just kind of a graphical representation. We want to go over to the parameters page, and this is where we want to get specifically in the section and profile name. To keep things simple, I'm just going to keep this really short. We'll go GR for guardrail, underscore A for the first part. Same thing for the profile. Now we're going to save this to the model directory. We could do this to the global, but that doesn't help you share with others. So either way is going to be whatever your choice is, and you can always export from the profile catalog to save in your firm folder if necessary. We're not going to adjust any of these other settings. As far as the profile attributes, there isn't something that really defines what we're creating here, so we're going to use the question mark. You can provide values here if you so chose. They aren't going to play a role in what we need to achieve, so I'm going to leave mine blank. I'm going to apply my parameters and then follow the prompts. Pick an object, and I shall do that. I'll select my first plate. It'll go ahead and then create a profile. Now, it's going to create it in space. It's going to create it perpendicular to the profile I have there. It's not the big deal, but we can see here I do have an extrusion. If I interrupt my command, come over here and inspect, it is actually a steel beam at the current moment, and it is a profile gr_a. Well, we're going to be able to refer to the profile catalog and grab that when we need to create a concrete beam. But before we do, let's go ahead and create the second profile. And there we have our second, slightly different. So now that we have these, we can proceed to go ahead and modify or create our concrete barrier. We'll snap back to plan, we'll close our dialog box, we'll save our model, and then we'll go ahead to the concrete ribbon. We'll choose our beam tool, and we'll go ahead and create an initial length between the grid lines, just for an example, 20 feet. So let's come in, take a look here, and let's go ahead and update our profile. We can search for it. It will be found under Others, or you could type it in the Properties pane. We'll hit Apply, OK, and then Modify, and there we are. You may have to adjust your position, and if so, I would suggest using the contextual toolbar to set the beam exactly where you'd like it to be. You can then rotate it into its proper orientation. There we are. We can go in the center. There we are. Let's do upward, just like that. Now, what I will do is I will copy this or create a new beam, whichever you prefer. I'll interrupt. I'm going to change this to 7'6". And let's go ahead and create one more piece or copy it. And we'll make that even shorter. We'll do 1'4". Great. The other thing I'm going to do, this piece is the piece we're going to need to manipulate. So what I have done here is my starting point, and I have two other segments. This represents my transition, and this represents my end profile. So what I need to do now is update this to be a different color so I can differentiate it visually. There we are. And then this, I'm going to go ahead and change to my other profile. There we are. So you can see here now, I have two different profiles. Now, the one thing I do want to make sure is that in my example, this back edge was always in line and that it tapered towards the upper right here, or to the northeast quadrant of our screen. So I'm going to move this and align it with the back edge. Okay, that'll give me slightly more dramatic transition here. So the question is now, how do we create that transition? I have three pieces of beam that are extrusions using a profile from the beam tool. Well, we can't manipulate this geometry in the way we need to go from this profile to this profile as a part. However, we can convert this to an item and then edit its geometry. And so if we select our piece, we can go ahead and choose either create a shape from geometry or convert part to item. Now, they both achieve the same thing in that they create an item shape based off of this geometry. The first one will create a shape and put it in the shape catalog, but this still remains a beam and a part. On the other hand, this will convert it in place to an item, and that's what we're going to do here. Keep in mind that when you do this, it erases all of the UDAs populated, as well as takes some attributes from its grid location, as well as the name, as part of the shape name. So I'm gonna go ahead and give this a unique name there to help differentiate it. Then I'll select it, right click, convert part to item. You'll get your warning. All UDAs will be wiped clean, so hit yes. And now this is a concrete item, not a beam. And that's exactly what we want. Because once we select this and we have our direct modification turned on, we can edit this part's geometry. And we can use that when we select it with direct modification turned on. The geometry editing ribbon will pop up here at the top. If we turn on our handles, we can see our points that control all the end or axes or edges on our shape. Now, we naturally want to just come and drag this over here, but you can see it's not letting me. And the reason is we need to create surfaces that allow flexibility for our endpoints, and we use that by the edge tool. So let's take our backside here, And we'll go ahead and choose the edge tool. Essentially what we want to do is bisect the part face, or sorry, the item face that we want to edit. So if it's this rectangle here, we want to bisect that with an edge diagonally. There we are, right? So now if I interrupt this and I select my piece again and turn on the handles, you're going to notice that I'm going to be able to drag this over now, right? There we are, back edge aligned properly. So now we just need to repeat the same process over here. This is actually pretty straightforward, but if you're not aware that this feature exists or you haven't played around with it for some time, you might not be familiar on how to go about it. So once I've bisected both this tapered face here and this foundational face here, I'll turn back my handles and we'll go ahead and drag it into place. All the points. You can see here now we get a nice concrete transition. Right? Let's go ahead and snap to plan and take a look at that. There we are, right? This is a simple example, but you can really kind of do this with just about anything. The real key here is bisecting your face that you want to edit. So going from the control point you want to diagonally across. Now, keep in mind, you can go and make a crisscross and separate this into 4 separate triangles, but when you do so, you cannot cross over an edge like this that is already established. Notice when I snap here, I give it a red line, but if I snap to the center point here, then I can create that and then continue that from the other side. So there's a tip right there. Make sure you don't get frustrated trying to cross over an edge you've already created, because you won't be able to. The other thing is that if you don't like these lines showing up, some of them can be deleted. If you turn on the handles again and select the edge, you can hit the delete key and you should be able to get rid of some of them. So visually speaking, you might be able to kind of clean up your concrete a little bit. Now that may not happen for all of them, but some of them will definitely cooperate with you. So the bigger question is now that we have this transitional piece, what do we do with it? Well, again, it's given us an interesting shape name, which we can find in the shape catalog. And if we open that up, we can go and see it right here with a little bit of preview. If you really care to or need to reuse this in other places, you could export this shape, or you could simply copy this piece of object using copy from another model into your next model, whichever you so choose. The other thing that we'll want to keep in mind is now that we have this piece, well, how do we combine it, right? Well, the easy answer in all reality is turn on pour view and you're done. Okay, allowing our pours to merge when we turn on pour view will give us one contiguous piece of concrete that transitions. This is really helpful, right? We can then go ahead and quickly inquire it to get its volume. This can be part of a larger pour, which will be quantitatively reportable. But you know, that's only one method. The other method, if you want to get like linear footage of something like this, pours don't really help with that type of metric. So you can come up to the edit ribbon and you can go attach to part. You select the part you want to attach to your main part and then the subsequent parts, and then click your middle mouse wheel, and then it will merge those parts together. This is a little trickier if you need to make updates or adjustments to the geometry. You'll have to explode this, which you can do from the drop down there. Pours are a lot more convenient, but essentially I can get the linear foot of this 28 feet 10 inches. And so there you are. And that's how you go about modeling a basic concrete transition without having to creating a new parametric profile. It's important to note that you can take this further, right? We can define separate profiles and then create from our options a variable cross-section that would do this transition for us automatically. And that is very useful if you're doing this kind of work repeatedly. But for the one-off situation and you just need to get it done and move on so that it's accurate, but it isn't a part of your everyday workflow, this method will suit you just fine. This concludes our video on concrete transition parts. Thank you for watching. Want to learn more about this topic or how to get started with Tekla Structures? Just check out this video's description for links to our user assistance page, getting started guide, and our online campus.